So in lesson 9.5, we're going to see another method for how we can solve a quadratic function or equation, and we're going to do this using a method called complete the square. So if we look at this, that's supposed to be x squared. Thinking about what value for c is going to make this a perfect square. So thinking about the visual, right? And you should have already done the complete the square Desmos activity first, so you can get that visual in your head. But we know that if our b term is whatever's being added or subtracted to x is going to be doubled, that would be 3. So if we square 3, we get 9. So the value for c that's going to make this a perfect square quadratic is 9. So that's the first part of this lesson, is just identifying what value goes here in order to complete the square. Basically, you're looking at your first and your last terms need to be perfect squares. And you're using your b term to figure out what number is squared to get c. So that's pretty much it. You'll do a worksheet where you're going to have a few practice problems like that. So if we look at a couple more, just to get some practice in, what value would go here? Well, we know that to make 12, we'd have 6. So this would be 36. Let's look at another one. What value would go here? Well, we know that to get 8, it would be 4 and 4. So this would be 4 squared, which is 16. We're only going to do this when a equals 1. Okay? So these are all 1s. Because it changes things when you have a coefficient other than 1 here. So you're only going to do this method with functions that have an a value of 1. So you don't need to worry about seeing other types of them. It's going to look just like x squared. Okay? Okay. So the next example is something that looks like this. So if we look here, 16 is not the square that makes negative 14, right? So we need to move this to the other side because these two don't add up correctly, right? So we subtract 16 on both sides, and now it's on this side. Now we can fill in here what would make this a perfect square, knowing that we need negative 14 as our answer. Well, to get negative 14 when we're adding, it would be negative 7 and negative 7 added together, which means that our last term would be positive 49. If we square negative 7, which gives us negative 14 as a sum, we get positive 49. But if we add 49 here, we have to add it to the other side, right? So we add 49 to 16 as well to keep our equation true and balanced. So we can now rewrite this as a squaring a binomial, right? So this becomes x minus 7 squared, okay? That's how we get this. So we're just writing it in almost vertex form, and we're going to be practicing that soon too. And then negative 16 plus 49 gives us 33. Okay, so now we're going to use our solving using square roots to get x by itself. We take the square root of both sides. We get x minus 7, because this undid the squaring of x minus 7, right? And then we get plus or minus the square root of 33. Remember that once we take the square root, it can be a positive or negative number inside here. And it's okay that, or not inside here, but the answer to this could be a positive or negative when you find the square root of it. It's okay that it's irrational. Don't worry about that. We're going to leave it that way. The last step we do to solve for x is we add 7 to both sides. So x is going to be 7 plus the square root of 33, and it's going to be 7 minus the square root of 33. because we said here that it was plus the square root of 33 or minus the square root, right? Because this in itself represents the solution once you found the square root. This is all you have to do. Leave it just like that. You don't need to evaluate it in the calculator because then you'd be rounding because this is irrational and you don't want to round. That makes a less accurate answer, okay? Now, you could put this function into Desmos. Don't put equals 0, put equals y, and you should see the two solutions for x will be at these values, but you would have to calculate it to see what that is about approximately. But anyway, that's just another way to check. Okay, let's do another one. All right, so again, we cannot get 10x, and this isn't even a perfect square because it's negative, so it's not possible. So we're going to add 9 to both sides. And we're going to fill in our c value here. To get 10, we'd need 2 5s, so we get 25 as the square at the end. We add 25 to both sides. Rewrite this as x plus 5 squared equals 34. Find the square root of both sides. It cancels that out. X plus 5 equals plus or minus the square root of 34. Again, not a perfect square, so we leave it like that. And then we subtract 5. So our two answers are -5 plus the square root of 34 and -5 minus the square root of 34. So I'm going to give you a problem to try on your own and then pause it and come back and check your answer and see how you did. Make sure you pause it, try it, and come back and check. Okay, so these are the two answers that you should have got. If you did it correctly, nice job. 4 plus the square root of 22, 4 minus the square root of 22. Okay, so last thing we're going to do in this lesson is we're going to use the complete the square method to write our quadratic equation in vertex form. So this is going to be really helpful in writing it in vertex form. And I know a lot of you like vertex form when it comes to graphing and things, so this will be nice for you to be able to go learn how to do that. So let's say we have x squared minus 8x plus 11. And think about it, in vertex form we have y equals, right? So we're actually going to put y equals here. And also we would need that if we graph it. So as you can see, this is not the square, the perfect square number that makes -8. What would we need? 2 -4s. So we're going to do the same process that we did. And we're going to put our, we subtract 11, right? We move it, actually it's going over here now because it's the y equals. So we're subtracting 11. And what number would go here? Well, if you square -4, you get positive 16. But now we've got to add that 16 here, right? We subtracted 11 on both sides. It moved over here. We added 16 because that's what makes this the perfect square. And now we need to add it here. So this now becomes y plus 5, right, of -11 plus 16 equals, we write this with our parentheses, and it's x minus 4 squared. That's what gives us this. We're almost there. I hope you can see the pattern here. This is almost vertex form, right? We have our h, we just need our k. Where's our k? It's over here. We're going to subtract 5 on both sides. So we get the quantity x minus 4 squared minus 5. What would our vertex be in our graph? It would be 4 and negative 5. HK, right? HK. Okay, so let me give you a couple to try. I feel like you should get this part down pretty well. If not, make sure you ask questions in class. So we have x squared minus 10x. No, I don't want to do that one. Remember to put your y equals when you do this. So I want you to try that one. And then try this one. Actually, I'll just put the y equals here. I don't want you to forget that part. Okay, pause it, try it on your own, and then come back and check the answer. Okay, so let's see how you did. This is the answer to the first one. This is the answer to the second one. So to recap, we have learned 3 methods prior to this for how to solve quadratic equations. First, we did graphing, where we literally just put the equation into Desmos or into a graphing calculator, looked at those 2 x-intercepts and identified those as the solutions or the roots, same thing, right? We solved these by factoring. So we put them into 2 binomials, and then we knew that those 2 numbers inside the parentheses represented the x-intercepts. And we also used square roots to solve the quadratic equations, where we put them, and you could do it this way like the one before, but where you use the square root literally to undo what's being squared. And now we've learned to complete the square, so manipulate it a little bit differently, which allows us to not only solve it, but also convert it into vertex form pretty easily. So those are the things that we've done. You guys also, now you're going to do your worksheet and finish the Finding Zero Desmos.